This is GMATS 41. You are welcome to our ordinary differential equation class. In this video, we now want to start with the first form of ordinary differential equation known as the separable variable equation. It's very important for you to be able to identify a particular form of ordinary differential equation so that you know the technique to apply in solving it. Now, how do we identify the general separable variable equation? Now look at it written on the board here. This is how the equation usually appears, alright? Now identify your differential coefficient dx. I call it parent. Differential coefficient dy, I also call it parent. This will be controlling x variable, this will be controlling y variable. Now however, in separable variable equation, you have function of x multiplying a function of y. And then function of x also multiplying what? Function of y. That is the form in which separable variable equation generally takes. Although there are still special form of it, but in terms of, in general, this is how they usually appear. Where function of x and y are being multiplied. Now what do? You're going to find a way to separate them. Okay? Since they are being multiplied, to separate, you have to divide by something. For example, coming here. Alright, now after transferring this function to the right hand side, you have this. You see, this sign can either be plus or minus. Once it crosses, alright, it will change sign. That's why I have minus or plus, as the case might be when the problem is given to you. After crossing this, now how do I separate the variable? Like I said, you identify your parent here, this is the x. So this g2y will be removed because it's a function of y. It shouldn't go with the parent dx. Then here, this is the parent dy, the differential coefficient. So you should carry only y variable. It therefore means that your f2x here, this f2x, has to be what? Removed. So the question is, how do we remove your g2y from here, and how do we remove f2x from here? Mathematically, because there is multiplication between these two functions, function of x and function of y, to remove this g2y, you have to divide. Which means you divide here by what? By g2y to remove this y variable. And then come over here, divide here by what? f2x to remove this x variable from the parent dy, from this differential coefficient dy. Now, did you take note that in all, what I did was to divide by what? f2x, I used it to divide, and then what? g2y, I used it to divide. Now, if I put 1 on top, you know, if you're dividing something by another thing, is the same as 1 over that another thing times the something. Look at it. A divided by B is the same as 1 over B then times A. Does that make sense? So all in all, what you do to this equation is simply to use 1 over f2x g2y. That is a function of x that you need to remove from y, and a function of y that you need to remove from x. 1 over their multiplication. Use it to multiply each of the terms. That's what you have here. Now, why I had to write it out like this is there is a name we give to this. We call it integrating factor. We call it what? Integrating factor of separable variable equation. So take note of that. You have to put it down, okay? Now, once you do that, what is going to happen? This g2y will cancel this g2y so that f1x over f2x will be left. Then you come here, this f2x over f2x will cancel so that g1y over g2y will be left with their parent. And that's what you have here. Once you've separated, the next thing is to integrate. And that's why you have your integration sign here. Just look at it and then ask yourself which technique of integration will apply depending on the problem that you are solving. So, we are done with explaining how to identify a separable variable equation and how to separate using integrating what? Factor. Please don't go cramming this, memorizing it, no. Once a problem is given to you, you will definitely know which one is the f2x and which one is the g2y, right? In the next video, we're going to pick problems, questions to solve, and then it will even become much more clearer. So we have this problem on the board. We are asked to solve the equation xy squared dx minus x squared y dy equal to 0. Now I want to transfer this minus of this term to the right hand side. If it crosses, it becomes positive x squared y dy. Now looking at this, what is the controlling parent? The differential coefficient here is dx. Is that not so? Look at it. It means that y variable should not be here. What is the correct? Okay, let us start it. Y variable must be removed from there. The controlling differential coefficient or parent there is what? dy. So what shouldn't be here? X squared should not be there. Therefore, in separating the variable, I'll divide it by y squared. Is that not so? And divide it by x squared. Whatever I do here, I'll also do it here. Whatever I do here, I'll also do it here. See how fun it is to play with, right? So let's do it and see. This is xy squared dx. I'm going to divide here by y squared. Then equal to x squared y dy. I'm going to divide here by what? X squared. Alright, now whatever I do here, I'm going to do it here. So I will bring y squared as a divisor here. And then I divided here by x squared. You take note, is that not so? So I'll bring it here, x squared. Did you take note that actually what I did was to multiply these terms by 1 over x squared times y squared. In case you are asked what is the integrating factor of this, look at it. 1 over x squared y squared. Is that okay? Now let us move on. Having separated this y squared, we cancel this y squared. Is that not so? This x squared, we cancel this x squared. Now watch something. This x in the denominator is x times x. You know that, is that not so? So if this x divides itself, it will cancel one of the x from there. What is left in the numerator now is 1. You know that. And then here, the same thing. This y will cancel one of the y from the denominator. Then in the numerator, it will be left with what? 1. Having done that, we now have 1 over x dx equal to 1 over y dy. We have separated. The next thing is to integrate. Now looking at this, how do we integrate this term? Integral 1 over x will give you ln x. Why? According to use substitution technique of integration, if you differentiate denominator and you get numerator, the answer is simply ln of the denominator. I hope that has entered the brain, right? Then we'll move on, equal to, come over here, you still get ln y, then plus ln c. Please take note, I know that you might be expecting plus c. Since everything is carrying ln here, even if I introduce ln c, ln to that constant, I commit no crime. Are you getting me? It has to be in that form, because every other term here is bearing ln. Besides, this is a constant, so even if it is c, and you take ln of c, ln of a constant will still give you a constant. So you are still mathematically consistent and correct here. Is that okay? Now let us move on. I want to do something else. I want to take this ln c to the left hand side and tell you one other property again of constant of integration, ln x. If this ln c is crossing, I know you'll be expecting it to become minus, but I'm telling you no, it will still remain plus ln c equal to ln y. Again, it is another property of constant of integration. Even if this crosses, because it's a constant, it will still remain positive. Are you getting me? If it is eventually going to be minus, when you solve the particular solution problem, the minus will come out naturally. But when solving to obtain the general solution, please, you maintain this problem. Now, ln is the same as logarithm to base e. We know that, is that not so? So laws of logarithm also apply to it. And you know, according to laws of logarithm, if you are adding log of numbers, alright, as long as the logs are in the same base, you pick one of the logs, in this case is ln, then multiply the numbers, c times x, and everything will be equal to ln y. At this point, take exponential of both sides. The essence of taking exponential is to remove this ln. Are you getting me? So we're going to have exponential ln cx equal to exponential ln y. What does exponential do to ln? It clears it off. Therefore, y is equal to cx. And this is the solution of this ordinary differential equation. We have this past question on the board here, 2011-2012. We are asked to solve the equation. Look at it. It's a differential equation. Observe that this is a separable variable equation because you have x variable multiplying a dy term, that is a y term. And then also x variable multiplying a y variable here. And so we can separate them. Now let us solve. You have the options here. So you're going to solve to target what the correct option. 1 plus x squared dy. We're going to take this term to the right hand side equal to xy dx. Next, identify the controlling parent, the controlling differential coefficient. Look at one here, dy. Look at the other one, dx. Since this is dy, this term has to be removed because this is an x term. Since this is dx, this y term has to be what? Removed. Now if I'm removing, I want to do that straight ahead, okay? You can take your time to check the terms and then bring out the integrating factor. This will be removed from here, so it will come down here as denominator. This y will also come here as denominator. If this y is coming here, since nothing is here from this part, we're going to have 1 over y dy equal to x will be left here, dx. This 1 plus x squared is coming here as denominator. In fact, if you look at this, the integrating factor is what? 1 over y bracket 1 plus x squared. Is that not so? Alright, so at this point we integrate. If you integrate this, what will you get? Ln y. That is ln of the denominator. Because if you differentiate the denominator, you will get 1 on top exactly. Equal to, how do you handle this integration? First of all, identify that the numerator and denominator, they belong to the same class of function, that is polynomial. So differentiate this denominator and see if you get the numerator. If I differentiate that denominator, derivative of this one is 0 because the constant goes up. Differentiate x squared, you get 2x. Did you take note that what I had in this derivative is almost the same as the numerator? The difference is just this 2. In cases like this, then the integration is going to be 1 over that 2, which produces the difference, ln of the denominator. Then plus c. But because everything is ln here, I'll put ln c. Please, at this point, because of this integration, I want to encourage you all and advise you to please visit our YouTube channel at GMAS41 and subscribe. We have basis of integration there. Even when we upload new videos, you can also learn from it and it will help you in this course a lot. Please take notes. Going to say let u be equal to something, you're using full U substitution technique. Of course, that's what we use here. But I had to use the technique observation sequencing procedure, which facilitates the result for us. So please subscribe to our GMAS41 YouTube channel. You will benefit. Now let's move on here. I'm going to write ln y equal to, using law of logarithm, this is the same as ln 1 plus x squared raised to the power half. I use power law of logarithm. Let me show you something. If I have a over b log c, according to logarithm, it is log c raised to the power a divided by b. Is that clear? So that's what I did here. Then plus ln c. Then again, this is ln y equal to, this addition, so you can pick one of the lns and then multiply the number c times x plus 1 plus x squared raised to the power half. Then take exponential of both sides. If you do that, the ln will disappear. So you have y equal to c 1 plus x squared raised to the power half. Now, at this point, you see, raised to the power half is square root of that thing that is bearing that power half. But look at this constant of integration. I've told you that it behaves in one funny way. Normally, this square root is meant to cover only this term. But I will use it to cover this c as well too, and I commit no crime. So our result is square root of c 1 plus x squared. Is that okay? Please take note, square root of constant of integration will still give you a constant. So you commit no crime. Therefore, the correct option is option C. And that's what we have obtained.